Hello, in this video we're going to do some general solutions to monopoly profit maximization problems. So here's the monopolist inverse demand. You'll notice this is just in general functional form here. Price equals A minus BQ. P is the per unit price, Q is the quantity of output. Here is a cost function also in just general form. Cost equals F plus M times Q, where Q is the quantity of output. The firm's revenue, the monopolist revenue, is price times quantity, where price is A minus B times Q. So the price is in the parentheses here, just making that substitution for P, and that is all multiplied by Q. Setting up the profit function, which is revenue minus cost. As we showed before, right up here, revenue is given by this first set of terms here on the right-hand side, and then we're going to subtract out cost. We're going to subtract out F, which is fixed cost, and then we're going to subtract out M times Q, which technically represents the firm's variable cost. So to maximize profit, we will first do a simplification here. This Q times A gives us A times Q, and this Q times minus B times Q is minus BQ squared. So just a little simplification. And now we are ready to take a derivative. We'll take the derivative of the profit function with respect to quantity. So the derivative of A of Q is A. The derivative of minus BQ squared, bring down the 2 in front, we get minus 2B times Q. What happened to this exponent? The rules of derivatives say we're going to subtract 1 from it, leaving us with just Q raised to the power of 1. The derivative of minus F is 0, and the derivative of minus MQ is just minus M, and that equals 0. We're going to solve this for Q. So just moving some things around here, moving this minus 2BQ to the right-hand side, and then we will divide through by 2B, and this is the profit maximizing output. To get the profit maximizing price, take this Q here and plug it into the inverse demand. So here's our inverse demand for Q. We're going to plug in this expression here. That expression now shows up in parentheses, and we can simplify it here. This B and B will cancel, and we could cancel a little bit more, simplify a little bit more if we wanted to. So just minus A divided by 2, and then minus minus, we're going to get plus M divided by 2, and then 1A minus a half A just leaves us with a half A plus M2. So that is a profit maximizing price. And what's different about this example is that I have a slightly more complicated cost function, but other than that, nothing changes. We'll get our revenue as price times quantity. Recognize that profit is revenue minus cost. For the revenue, we'll substitute in A minus B times Q, which is all multiplied by Q. And then we're going to subtract out cost, so minus F minus MQ and minus NQ squared. Simplifying the revenue a little bit, taking a derivative, setting that derivative equal to 0, and solving for Q. So at this step here, I just divided everything through by 2, and then I factored a Q. So dividing everything through by 2, factoring Q out of the expression over here, and now dividing everything through by B plus N, plugging this result into the inverse demand, and I'm not going to simplify it any further. We get our profit maximizing price. All right, I hope you found this video helpful.